Hello, this is Miss Cliffner with today's video lesson, and we're still working with number lines representing solutions of an inequality. So today's homework is a big ideas math, and I'm asking you to bring your record and practice journal page tomorrow. Okay, so here we go. This warm-up is asking you to go ahead and graph inequalities on a number line. And so what it looks like is I'm trying to find all the numbers n that are greater than 0. So I could do, let's see, a -2, -1. I'm skipping some spaces on my number line. So there's a number line. And remember, if you have an inequality that doesn't include the or equal to, it's an open circle. So basically, all the numbers that are greater than 0 start right next to 0, but not exactly 0. And then it travels in the direction where the numbers get bigger, right? So there is my graph of the inequality of all the numbers n that are greater than 0. Now for the second example, I have a greater than or equal to, and that one's going to be a closed circle. So I'm trying to find all the numbers that are greater than or equal to -3. So I could do something like this, -5, -4, -3. I'm just making a number line that's going to include -3, and I put a closed circle, and the arrow goes in the direction where the numbers get bigger. Right? Numbers get bigger to the right. That's how you graph the solutions to inequalities. Okay, so let's look at our notes. The set of all numbers that make an inequality true is called a solution set. Now that's a very fancy math name, and later on, like in 9th grade, you'll start putting these little fancy brackets, and you will actually make a list of numbers that are in the solution set. But all we're doing in 6th grade is graphing those solutions on a number line. Okay, so how to check if the solution to an inequality, if a number is a solution to an inequality. So here's what you do. You plug in the value for the variable. You do the math on each side of the inequality. Then you ask yourself if the inequality is true. If so, the value is a solution. And if it's not true, then the value is not a solution. Just like when we were checking equations, it's very similar for inequalities. Okay, so here's an example. Tell whether the given value is a solution of the inequality. So I'm going to plug it in. So instead of the x, I write 8. And I write 8 plus 1 is greater than 7. And then I do the math over here because there's none to do on the right-hand side. 9 is greater than 7. That is true. So I know that x equals 8 is a solution. So that's what I'm trying to do to determine if the value is a solution. All right, the next one, y equals 4. Plug it in, plug it in. A number next to a variable means multiplication. So I do 7 times 4 is less than 27. 7 times 4 is 28. 28, what? 28 is less than 27. Now, if you can't remember that an arrow that points this way is the less than symbol, sorry, not an arrow, but it's kind of like the arrow point, you can think about the crocodile always eating the bigger number. And right now, the crocodile's eating 27, so that is not true. Okay, so then I know that y equals 4 is not a solution, right, to that inequality. It doesn't make the inequality true. Okay, the last one, I'm plugging in 15. Remember, a fraction bar means division. So it's 15 divided by 3 is greater than or equal to 5. 15 divided by 3 is 5. So you ask yourself, is 5 greater than or equal to 5? And there's an or in there, right? So it is equal to 5, so it is true. So then I know z equals 15 is a solution. Move me. Okay, now I got some OYOs. Try these 3 on your own. Each time you're plugging in the number 3 for the variable, right? So n equals 3 or x equals 3. Pause the video, try these on your own. Tell whether the number is a solution for the inequality. Okay, so here we go. I plug in the 3 and I do the math. At first I write the whole inequality. Then I do the math. 7 less than 6. Oops, nope, not true. So b equals 3 is not a solution. All right, next one. plug in 9 minus 3 is greater than or equal to 6. 6 is greater than or equal to 6. Yes, that is true because 6 does equal 6. So n equals 3 is a solution. It works. And the last one is plug in 18 divided by 3 is less than or equal to 10. This is 6 is less than or equal to 10. True. So x equals 3 is a solution. Okay, so now the next thing we're going to do is look at the steps for graphing an inequality. So this is a little bit of review, and here's the things that I want you to think about. I want you to look at the number, right? The number that's being compared in the inequality, that's what you're going to be graphing. So maybe you want to think about, is it a positive or a negative, and do I know how to make a negative number line? Next, you're going to think about the scale that you'll be graphing. And are you going to skip count by 2s or 5s? I also forgot to talk about the open and closed circle, but you know, that's maybe number 4. Think about whether their circle is open or closed. Okay, and number 3, this is super important. Check to see if the variable is listed first. If not, rewrite the inequality so that the variable is first, but make sure the crocodile still eats the bigger value. So here's what I found in your textbook. They give you one little statement that they want you to look at, but it's an important statement. So it says the inequality G is greater than 2, but then that means the same thing as 2 is less than G. So here's how I want you to think about it, right? So my brother, so this is age, my brother is older than me, right? So I can say he is older than me, but also I can say that I am younger than him. So I basically did 2 things. I said my bro was older than me, and me is younger than my bro. So they mean the same thing, right? My brother is still older no matter what order I say it in. That's the idea with an inequality. So I'm going to take this inequality and I'm going to change it around. So instead of 5 being greater than or equal to x, I'm going to write it as x is less than or equal to 5. Now the reason I did that is because the arrow is going to match the inequality. I know because it includes the number 5, it's a closed circle. And the arrow goes in this direction because I am looking for numbers that are less than or equal to 5. So I want you to notice that if you write the number first, the inequality is in the opposite direction from the arrow. But if you write the variable first, the inequality is moving to the left, and so is the arrow. So it matches. Not that you have to rewrite it every time, but it's something to pay attention for and not do the arrow the wrong way. Okay, so now here's some Oyos. Try these, and that'll be it. Okay, if you want some hints first, I'm going to put some numbers on a number line just to make it easier. So I might put like -4 here, -3 here, and -2. And for here, I'm going to put 0 and skip 1, 2, 3. I'm going to make that a 1. And then for this one, I'll do 0, 1, 2. And then here, I'm going to do -3, -2, -1, and 0. Okay, so the variable is written first. So I know the arrow is going to match the inequality. So this is including -3, so it's a closed circle. This doesn't include 1/2, it's an open circle. This includes 1.5 closed circle. This doesn't include -2 open circle. So I already know my open and closed. So now, let's see, I put the closed circle at -3. I know I'm looking for numbers greater than -3, so I go in that direction and I make my arrow. The next one is x is less than 1/2. So 1/2 is right in the middle, right? This is where 1/2 is. It's an open circle, and the arrow goes off to the left. I'm looking for numbers that are smaller. Notice the direction of the inequality matches the arrow. Now when I get down to here, the number is first. I know it's a closed circle at 1.5. Okay, there's where my 1.5 is, but I want to switch the direction of the inequality, and I'm going to write it this way. But I want you to notice The crocodile's eating the 1.5 in the first one. The crocodile's still eating the 1.5. 1.5 is still bigger. I am looking for numbers that are smaller than or equal to 1.5, which is why my arrow goes off to the left and it matches the direction of the inequality. I'm going to rewrite number 11 and put A is greater than -2. Notice the crocodile is eating the A and still eating the A. So I need to have an open circle at -2 and the arrow goes in this direction. Okay, last thing I want to show you is how to do the homework. Okay, if you're doing the big ideas math, here is, let's see, let me move the window open a little bit. Okay, so here is example, this is number 26. I'm just going to move over the frame. Okay, so notice that the inequality that you are graphing is n is greater than or equal to 8. And notice these are the different symbols that you have down here. So notice that if I would just want to put a dot, I click on that, I can put a dot. But I'm not just graphing one number, right? I'm graphing a whole bunch of numbers that make the inequality true. So I'm going to trash that dot. And then I'm going to notice my arrow needs to go off to the right. And it needs to be on 8, and it needs to be a closed circle. So I look for, oops, that's an open circle. I look for the closed circle that's going off to the right. I click on that, and then I click on the 8, and it makes the line for me, and then boom, I'm done. I can check my answer, and it says I got it right. That's the idea of how you graph inequalities on a number line in Big Ideas Math. Okay, good luck.